to the next session of super elevation. In this video, we are going to see the numerical problems on super elevation. We shall start with some typical problems, very few problems. Before we start, let's just brush up the formulas that we learned in the previous video. So this is the condition for skidding on level road, for overturning on level road, condition for skidding on banked road, condition for overturning on banked road, and this is for rails, and this is the equation for super elevation. Okay, next, problem number 1. A circular automobile test track has a radius of 200 meter. The design of the track is such that when a car travels at a speed of 72 km/h, the force between the automobile and track is normal to the surface of track. Find the angle of bank or super elevation. So we need to find out theta u. It's a very simple problem. Let's see what is given. They have given you the radius, that is r is equal to 200 meter. Speed is given, v is equal to 72 km/h. They have given in kilometer per hour, but we want it in meter per second. So to convert, you can go with any method. I'm dividing it by 3.6. So I get it to be 20 meter per second. So these two are given data. Coming to the solution, we'll call theta be the angle of bank or angle of super elevation that we call as. So we also know that tan theta is equal to E by B from the triangle when we derived it, or it can also be written as tan theta is equal to V square into B by GR in case of roads. So taking the formula tan theta is equal to V square B by GR, since I have these data pertaining to the given question, V can be substituted as 20 meter per second. G, we know that it is 9.81, and R is given as 200 meter. So substituting this value and calculating, we get tan theta is equal to 0.2038. And again, if we solve further for theta, we get it to be 11.53 degree. And thus we arrive with the angle of super elevation. So this is the answer. It's a very direct question and it's a very easier one. Next, moving on to the second problem. The gauge of the railway track is 1.67 meter. How much the outer rail should be elevated for a curve of 500 meter radius so that the resultant force may be normal at a speed of 54 km/h. So they have given the gauge distance of a railway track. They have asked how much the outer rail should be elevated. That is, they are asking to find out E, the super elevated height, where radius is given so that the resultant force may be normal at a speed of 54 km/h. The speed is also given. So writing down the given data, gauge of the rail, that is G, is equal to 1.67 meter. Radius R is given as 500 meter. Speed V is given as 54 km/h, but we have to convert it into meter per second. So I divide it by 3.6 and I get it as 15 meter per second. Coming to the solution, we know for the railway condition, we are making use of G instead of B. We need to find out super elevation. They have asked for super elevation. Therefore, super elevation E is equal to V square G by GR. So this formula, we already know it. Substitute V, that is 15 meter per second. Capital G, that is 1.65. The small g is 9.81. And R is 500. If you substitute and solve, you'll get E is equal to 0.0766 meter. Or I can convert this into, since it's in the decimal form, I can convert it into millimeter. E is equal to 76.6 millimeter. So this is the super elevation value for this railway track. Moving to the problem number 3. Determine the speed with which a vehicle is moving around a curve of 50 meter without side slip on a level road. Second one is on a road banked at an inclination of 1 in 10. The slope is given. Also find the speed of the vehicle on a banked road without any lateral friction force. Assume the coefficient of friction between the wheels and the road is 0.4. So there are two parts to it. In this first part, for first condition, they have asked to find out the speed on a level road, then a speed on the banked road having an inclination of 1 in 10. The slope is given. The radius of curvature 50 meters is given. And for this, the coefficient of friction is given as 0.4. They have also asked you to find out the speed of the vehicle on a banked road without any lateral friction. So two parts are there. So coming to the solution, before that, the given data is here. Radius is given as 50 meter, coefficient of friction mu is equal to 0.4, and banking of the road at 1 in 10. That is, the slope is given. So I can take tan theta is equal to 1 by 10. That gives out to be 0.1. This much is enough. No need to find out theta. Coming to the solution, the speed on the level road, that we know the condition is V is equal to root of mu into GR. Mu is the coefficient of friction 0.4, G is 9.81, R is given as 50. So if you solve this, you'll get 14 meter per second. Since we have substituted in this, G will be in meter per second square, and R is in meter. So we get it in meter per second. So it's good to keep it in standard. So I multiply by 3.6, it convert it into kmph. So V is equal to 50.4 kmph. So this is the answer. This is the speed on level road. Next part is to find the velocity on banked road. We know the condition as velocity is equal to square root of gr into mu plus tan theta divided by 1 minus mu tan theta. G is known, R is known, substitute, mu is 0.4 given, and tan theta is 1 by 10, that is 0.1. Substitute all these values when you solve this, and you will get it as V is equal to 15.975 meter per second. And we convert this into kilometer per hour by multiplying 3.6, and we get V is equal to 57.51 kmph. So this is one part of the problem. In the second part, they have asked you to find this speed of the vehicle on banked road without any lateral friction. So it's a super elevated road, but there is no frictional force considered. Friction doesn't come into picture. So at that time, the equation is this one. Tan theta is equal to V square by GR. We need to find out the velocity. We know that tan theta is 1 by 10, that is 0.1, is equal to V square by G into R. R is given as 50. So if you solve this, you get V is equal to 7 meter per second. Convert it into kmph, and you get V is equal to 25.2 kmph. So this is the velocity you get when there is no frictional force and it is super elevated. So on all these questions, you need to assess what is the condition they have asked you to find out the velocity. Based on that, you decide which equation to make use of. So reading the question properly is very important here. And coming to the next problem, the last problem, problem number 4, a rail track with gauge 1.68 meter carries a locomotive weighing 1000 kilonewton running on a curved track at 60 kmph of radius 800 meter. Determine the super elevation of the track. Also determine the lateral thrust exerted on outer rail if speed of the locomotive is changed to 80 kmph. So until here 60 kmph, you need to find out the lateral thrust that is exerted when the speed changes from 60 to 80 kmph. So, taking down the given data, gauge is given as 1.68 meter and weight of the rail is given, that is W is equal to 1000 kilonewton, and speed V is equal to given as 60 kmph. I convert it into meter per second by dividing by 3.6. I get it as 16.67 meter per second. And radius R is equal to 800 meter. Coming to the solution, we can plot this diagram for this question. So it's a super elevated rail. It's raised on one end, and this is the weight of the rail acting vertically downwards. We have two contact surfaces, RA and RB, and there will be a thrust outside this road, outside this rail. So thrust will be on this side. Therefore, your frictional force will be on to the opposite side at this junction. Okay, and the angle of super elevation will be theta here. And this will be the centrifugal force WB square by GR. So coming to the solution, theta is declared as angle of super elevation here. We have tan theta is equal to V square by GR. This condition we have. Substitute V, that is 16.67 divided by 9.81 into radius is also given 800 meter. We solve further, we get it as theta is equal to 2.03 degree. So this is the condition when you need to find out for the super elevated surface. We also know that tan theta is equal to E by G. Therefore, from this super elevation, E is equal to, we can write G into tan theta. Actually, in banked roads, tan theta will be E by B. Since it is rails here, we are going to take tan theta is equal to E by G. So therefore, the super elevation is equal to 1.68 meter into tan 2.03. When you solve this, you'll get answer as 0.0594 m meters, since gauge is in meters. And multiply this with 1000 and you will get it E is equal to 59.54 millimeters. So this is the super elevation provided for the given data. So this is one part. Moving on to the second part of this question, we've asked you to find out the lateral thrust that is being up here, that is F, when the speed is increased from 60 to 80 kmph. So the new speed for us is 80 kmph. Convert that into meter per second, you get it as 22.22 meter per second. So now resolving all these forces with respect to the inclined plane. So we need to resolve all the forces with respect to this plane. Okay. So I can write this as minus F. Then I have the horizontal component of this force, that is WV square GR into cos theta in this direction, and the component of the horizontal component in this direction, horizontal component of W, that is this will be in this direction, so minus W sine theta. Writing all these things, no other forces in horizontal direction, that is the lateral direction, so I write equal to 0. Okay, so from here I can find out F is equal to WV square by GR cos theta minus W sine theta. So I can substitute all these values. W is given, that is 1000 kilonewton in the question. V is given here, increased to 22.22. G is known, R is also known, and cos theta is already known, 2.03 in the previous part. Minus W, again same, and theta is also. Substituting all these values and solving, we get the lateral thrust F is equal to 27.45 kilonewton. Since this 1000 weight is in kilonewton, your lateral thrust also will be in kilonewton. So the final answer, F is equal to 27.45 kilonewton. So these are the simple problems that we can see in super elevation. So these are the references that I made for these problems. Thank you for watching this video.